Okay, I'm going to show you how to solve exponential and log equations. And this could be by rewriting the base. It could be by changing to exponential or log. Let's look at the first example. We have 9 raised to the x minus 3 equaling 729. Okay, so we need to ask ourselves, is there a way for me to rewrite 729 using a base of 9? You might need your calculator, as 729 is a larger number, but yes, we can rewrite 729 as 9 cubed. Well, now we need to say if we have base of 9 raised equals base of 9 raised. Well, what must be true? My bases are equal, then my exponents must be equal. So x minus 3 equals 3. Now we can isolate the x, add 3 to both sides. X equals 6. And how do we know if we're correct? We can plug it in. 6 minus 3 is 3. 9 cubed is indeed 729. So I can box my answer. So that is one way of solving. Well, what if your brain doesn't figure out that 9 cubed is 729? You're just going to be stuck with the first part. So if you want another way to solve it, option 2. Option 2, when you have 9 raised to the x minus 3 equaling 729, is we could change it to log form. So if you're stuck in exponential, well, let's change it to log. Well, this is log base 9 of 729 equaling x minus 3, the exponent. And then I can just isolate the x. How do I isolate the x? I can add 3 to both sides. So I have log base 9, 729. Again, you are not adding 3 to the 729. You have to add it on the outside. Remember, log is a mathematical operation being applied to 729. And again, you can put this in your calculator and you should still end up with 6. So again, if your brain doesn't think of the base and the exponent, again, you can try to change it to log form. Either way, x equals 6. So let's look at another problem. So what if we have 5 times 2 to the x plus 4 equals 15? Okay, well, our first step is we need to try to isolate the exponential. Well, it's not isolated because it's multiplied by 5. So we're going to divide by 5. So 2 to the x plus 4 equals 15 divided by 5 is 3. Well, now we need to ask ourselves, is there a way for us to write 2 raised to a power to equal 3? Well, no, because 3 is prime. So since we're stuck, we're going to change it to log form. Well, this is log base of 2 of 3 equals the exponent x plus 4. So all we got to do is isolate the x. How do we isolate the x? We can subtract from 4. So again, how do we write our answer? Log base 2 of 3, all of that, and then minus 4 equals x. Do not subtract 4 from 3. It has a log applied. Again, SAT likes to use change of base formula, so you could also see it written as log base 3 divided by log of 2. Remember, base on bottom, and then minus 4. You could see a multiple choice answer written like that, or you could approximate it at negative 2.415 and let the calculator give you a decimal answer if needed as well. Okay, so notice that all 3 of these are equivalent depending on if it's a multiple choice answer, what form the answer choices are in. Okay, so let's look at another one. So what if we have 5 e to the 2x minus 4 equals 11? Well, first step is we need to isolate the exponential. So if we isolate, that means that we need to get e to the 2x all by itself. So what is the furthest away? Furthest away is the minus 4. So inverse operation, we're going to add 4 to both sides. So 5 e to the 2x equals 15. Again, we divide by 5. E to the 2x equals 3. And now I'm stuck. Okay, there's not going to be a way for me to rewrite 3 using a base of e again, so we need to change it to log form. Since it's a base of e, we have special log, we have natural log. Remember, natural log automatically has base of e. I don't need to write that. So natural log of 3 equals the exponent to x. And then we can divide everything by 2. So x equals the exact answer of a natural log of 3 divided by 2. Again, if you're looking for other ways that this answer could be written, again, they might pull out the 1/2. Again, you could also estimate it as the decimal and use your calculator. So just letting you know that these both are the same. Okay, let's look at one last one. So what if we have 2 log base 5 of x equaling log base 5 of 4? Well, my first step is, well, are my logs isolated? And they are not, because I have this 2, but I have a property of log that states that, well, 2 times something, Jup could be put as the exponent. So log base 5 of x squared equals log base 5 of 4. Well, now that the logs are separated, well, what do I have? Log base 5 of something equals log base 5 of something. Well, what must be true? My somethings must be equal. So these logs of 5s are going to cancel. And if these are equivalent statements, that means that x squared should equal 4. So isolate the x. How do I isolate the x? I'd be taking the square root of both sides, right? So x equals plus or minus 2. So this problem is a little different because we're dealing with logs. So I have 2 possible answers. I have a possible answer of x equals 2, and I have a possible answer of x equals negative 2. Well, let's look at 2. If I plug in 2, I have a log base 5 of 2. Well, that's okay. I can take the log of a positive number. I can accept this answer. But remember that the graph of logs do not have infinite domain. The domain of a log graph, plain Jane parent function, just log x, is going to be from 0 to infinity, not including 0. So I cannot take the log of a negative. So let's look what happens when I plug in this negative. If I plug in log base 5 of negative 2, well, that can't happen. I cannot take the log of a negative. This would be saying that 5 raised to something gets me negative 2. Well, 5 raised to nothing will get me a negative number, because even if I have a negative exponent is just a fraction. You get a smaller positive number. So this is what we call an extraneous solution. You cannot ever, ever, ever take the log of a negative. So plug it in. If you plug it in and it becomes positive, then that's fine. But since this negative 2 that we're plugging in is taking log of negative 2, nope, reject. That's extraneous. We can only accept 2 as our actual answer. So be very careful in regards to solving logs. Make sure to double check at the end, as log functions do not have infinite domain.